Hello students. So today we're going to discuss on the topic of applications of integrals and area under a curve. Okay, it's a very important topic for your CBSE examinations. Definitely you're going to get a question from this topic. So today we are going to discuss on only two topics under this. Area under a simple curve and area between two curves. Okay, so first of all, let's try to understand what is happening over here. Let's directly go to the concept. You can see over here, I have made an x-axis and a y-axis over here. Okay, you can see x-axis and a y-axis. Okay, and in this, I'm going to represent the curve y is equal to f of x. And you can definitely see that I can bound an area between x is equal to a and x is equal to b. Fine. And I'm going to find the area under this curve between x is equal to a and x is equal to b up to the x-axis. Up to the x-axis. And the expression is so simple. It is integral of a to b y dx. Integral of a to b y dx, because the expression for the area is the expression under the curve y is equal to f of x. Okay, so the expression is so simple. You have to do the definite integral a to b y dx, which computes the area under y is equal to f of x up to the x-axis. Under y is equal to f of x up to the x-axis. Next concept is a very simple concept again. We're going to discuss about the area between two curves. Area between two curves. Okay, again let's take the two axes. X is equal to x-axis, y-axis, and you can see two curves here. The first one is y1. Can you see y1? Yes, y1. y1 is equal to f of x. The second curve is y2, right? y2 is equal to g of x. So you can definitely see that these two curves are intersecting each other at 2 points. These two curves are intersecting each other at 2 points, and we're going to call those 2 points as x is equal to a and x is equal to b. X is equal to a and x is equal to b. Fine. So let's try to understand the concept once again. I'm talking about area between two curves. Okay, now we're going to find the area that is enclosed between these two curves. The area enclosed between these two curves. Fine. How do we find it? How do we find it? Very simple. Now just try to remove the curve below. y2 is equal to g of x. Remove it. Now if you find the area under the first curve, y1 is equal to f of x, you get the area from the normal equation integral a to b y1 dx, right? Integral a to b y1 dx. That is the area under the first curve. Okay, up to the x-axis. Up to the x-axis. Next. Now we'll put back the second curve y2. Put back y2 is equal to g of x. Okay, and then remove the top curve. Remove the top curve. Fine. And when you remove the top curve, you're getting the area from x is equal to a up to x is equal to b from the curve y2 is equal to g of x up to the x-axis. From the curve y2 is equal to g of x up to the x-axis. Right? This curve is going to give you the area under y2, right? But actually, what is the area that I need? Okay, bring back both the curves again. y1, okay? y1 and then y2, both the curves are back. We want the area enclosed between. So first we got the area under y1 up to x-axis. Then we are getting the area under y2 up to x-axis. Now you get what? The area between the two curves. So what should you do for that? y1 minus y2. Okay, y1 minus y2. So expression is going to be integral a to b y1 dx. We wrote first minus integral a to b y2 dx. Integral a to b y2 dx. Is it clear, all of you? Is it clear, all of you? I think the expression is now very clear. Okay, now let's get out of this now. Let's do one simple example question. We're going to do the Look at the question on the board now. Find the area enclosed by the circle x squared plus y squared is equal to a squared. X squared plus y squared is equal to a squared. So now let's represent the circle very clearly. Yes, you can see the circle now. See the x-axis there? The x-axis is coming, okay? The y-axis is coming, okay? Now, from the equation is very clear that this is the standard equation of a circle, which is x squared plus y squared is equal to a squared, has center. The center of the circle is the origin 0, 0, and the radius of the circle is a. This is the standard equation of a circle having center 0, 0 and origin a. Let's draw it. Okay, come on, the circle coming. Okay, see that? The circle is coming, and I can see that the center is at the origin 0, 0. The center is at the origin 0, 0, and the radius, see that highlighted part? The radius is a. Now, how to find the area over here? Okay, now you can see that this circle is divided into 4 symmetrical parts. 1, 2, 3, and 4. Yes, all of these 4 parts are equal in area. So I will not go for finding the entire area. I will go for finding only one area. Remove the 3 parts. Remove the 3 parts. Only the first part, which is of the first quadrant. So I will find the area like integral area is equal to 4 times the integral from 0, x is equal to 0 up to x is equal to a, y dx. Now, we need to find the y of this circle. We need to find the y of the circle. For that, let's go for it now. So from here, I can say y is equal to the square root of a squared minus x squared. Y is equal to the square root of a squared minus x squared. So that is equal to 4 times the integral of 0 to a, the square root of a squared minus x squared dx. Okay, now this is a formula. This is a formula from integration. Integral 0 to a root of a squared minus x squared, that is equal to 4 times x by 2 root of a squared minus x squared plus a squared by 2 sine inverse x by a. Okay, and the limits are from 0 up to a. The limits are from 0 up to a. Okay, now integrate it, my dear students. Integrate it, that is going to be 4 times. Okay, substitute the value of a. This is going to become a by 2 times 0. Okay, plus a squared by 2 sine inverse of 1. Okay, if you substitute the value of a over here, it is going to become a by a, which is equal to 1. Simplified form. And okay, forget about the first one now. The second one is completely 0, because when you put 0 over here, it is 0. And when you put 0 over here, it is 0. So my final answer is going to be 4 times a squared by 2 times, okay, sine inverse 1 is pi by 2. Okay, so final answer is pi a squared. Pi a squared. Now let's verify it. Am I right or not? Am I right or not? So this is a circle with radius a, right? What is the formula for finding the area of a circle? Pi r squared. Pi r squared, right? Radius a. Radius a. So the area is pi a squared. So using application of integrals also, I found out that the area is pi a squared. This is how you use application of integrals to find the area under a curve. So this example is just for area under simple curves. So we will come back again with another concept on another day. Thank you and have a very nice day.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.